Hi everyone, welcome to my YouTube channel. In this video series, we are planning to talk about the application of statistical methods in manufacturing industry. In this video, we will be looking at probability plot. The question that we would like to answer is, how do we know whether a particular probability distribution is a reasonable model for our data? Probability plotting is a graphical method for determining whether sample data conform to a hypothesized distribution based on a subjective visual examination of the data. To construct a probability plot, the observations in the sample are first ranked from smallest to largest. For example, the sample x1, x2 until xn is arranged as x1, x2 till xn, where x1 is the smallest observation, x2 is the second smallest observation, and so forth, with xn the largest. The ordered observations are then plotted against their observed cumulative frequency. The plotted points will fall approximately along a straight line. If the plotted points deviate significantly and systematically from the straight line, the hypothesized model is not appropriate. Usually, the determination of whether the data plot follows a straight line is subjective. For example, we hypothesize that these numbers in this table are adequately modeled by a normal distribution. Is this a reasonable assumption? Probability plots are often the first technique used when we need to determine which probability distribution is likely to provide a reasonable model for data. To illustrate how probability plotting can be useful in determining the appropriate distribution for data, we will use Minitab and Matlab to construct the plots. First, let's start with Matlab. We show two examples of probability plot for normal and y-ball distributions. Here we generate sample data with size of 1000 from a y-ball distribution with the scale parameter 0.5 and shape parameter 2. And then we will use histogram to recognize the distribution and then plot probability plot. It's clear the data follow the straight line, so we can use y-ball distribution function to model these data. To interpret a probability plot in Minitab, we need to take 3 steps. Step 1. Determine whether the data do not follow the specified distribution. We need to compare the p-value to the significance level. Usually, a significance level of 0.05 works well. If the p-value is less than or equal to the significance level, the decision is to reject the null hypothesis and conclude that your data do not follow the specified distribution. If the p-value is larger than significance level, the decision is to fail to reject the null hypothesis because you don't have enough evidence to conclude that your data do not follow the specified distribution. However, you cannot conclude that the data do follow the specified distribution. Step 2. Visualize the fit of the specified distribution. Examine the probability plot and assess how closely the data points follow the fitted distribution line. If the specified theoretical distribution is a good fit, the points fall closely along the straight line. Step 3. Display estimated percentiles for the population. Hold the pointer over the fitted distribution line to see a chart of percentiles and values. Here is the data. As part of the initial investigation, we create a probability plot to check for normality and to evaluate the distribution. The data points are relatively close to fitted normal distribution line. To do this, go to Graph and then select Probability Plot. Then select Single. In the Graph variable, select Weight or column C1. Select Distribution and then select Normal and hit OK. The data points are relatively close to the fitted normal distribution line. The p-value is greater than the significance level of 0.05. Therefore, we fail to reject the null hypothesis that the data follow a normal distribution. Hold the pointer over the fitted distribution line to see a chart of percentile and values. A probability plot graphs each value versus the percentage of values in the sample that are less than or equal to it along a fitted distribution line. You would expect 5% of population to have a weight of 12.74 or less. We are going to release video series on different topics including application of statistics in manufacturing and quality control, robotics and mechatronics, industrial machine vision, system dynamics, finite element analysis with abacus, GD&T and tolerance analysis, and many other interesting topics. Don't forget to subscribe to this YouTube channel to get notified when a new video on this topic is released.